let's try to understand Sally's approach a little bit better. So Sally is suggesting we go with the EOQ model. So again, a quick recap. What's the formula for our EOQ or Q star? So this is square root of 2 times the transaction cost times the demand over the cost of having excess inventory. So do we have these numbers? Yes, we do. And how do we move? 2 times CT is 100. Our annual demand is 5,000 divided by CE, which we can calculate from C times H, which was $2 per unit, times H was given to us as 0.28. So this gives us a value of 1 million divided by 0.56, and if you solve this, you will get a value of 1,336 units. Okay, so now that we have our EOQ number, the unit of 1,336, let's try and calculate the total cost using this EOQ. Once again, we will calculate the purchase cost plus ordering cost plus holding cost. So what is our purchase cost? Well, nothing has changed here, so it's $2 per item, and we order 5,000 units in a year, so this gives us 10,000. Okay, what about the ordering cost? Is this affected with the new EOQ? Yes, it is. So the ordering cost is still 100 per order. However, the number of orders we will make will change, because this time is 5,000 divided by 1,336 and not 500. So this gives us a value of $374. What about the holding cost? Will this be affected with the new EOQ? Yes, and the formula is CE, or cost of excess inventory, times the average inventory on hand. So we have done this before. We have calculated CE to be 0.56. The average inventory on hand, however, is Q by 2, and this time our Q is 1,336 divided by 2, and this again gives us coincidentally a value of 374. So we have the purchase cost, the ordering cost, and the holding cost. Can we calculate the total cost? Yes, you just add these three up, and this should give you a value of $10,748. Well, while we are here, can we also calculate the order frequency? I think we were asked in the question for the order frequency. Yes, so we order 5,000 units in batches of 1,336. This gives a value of 3.74. Let's round it off to 4. What it means is roughly 4 times an year, or 1 order every 3 months. This becomes our order frequency. Let's now try to understand Bob's approach. Bob doesn't suggest we change Q. So when we don't change Q, would our total cost be different? Let's calculate. Again, this total cost will have a purchase cost component, an ordering cost component, and a holding cost component. Let's see which of these three is impacted with Bob's suggestion, which is to put down the ordering cost or the setup cost from $100 to $25. So the purchase cost still is at $2 per unit times 5,000 units that we sell, or the Coop sells in a year, right? So this gives us a value of $10,000. I think this is the same as the first case in part A. What about So this is your purchase cost. What about the ordering cost? Is this impacted? Well, the ordering price per unit is now 25 in Bob's suggested approach. But the number of orders still remains the same, 5,000 divided by 500, which gives me a total value of $250. What about holding cost? Will this change? Well, what's the CE? CE is C times H, and our C is again $2. Our H was 0.28, and this goes with average inventory on hand, which is 500 times divided by 2. So this doesn't change. We still get the old 140. Can we calculate the total cost now? Yes. Add these three numbers up, and what we get is a total cost of $10,390. And yes, this is a little bit cheaper than Sally's solution. How about order frequency? Can we calculate the order frequency here? Sure. So we know the demand is 5,000 units an year, and we are ordering in batches of 500, so we end up ordering 10 times per year, or one order every 1.2 months. So this is the same as part A. Nothing changed here. Okay, so let's now move on to the next part, which is, can we do even better than Bob or Sally? Or between Bob and Sally, it does look like Bob's approach is better, but let's think a little bit more. What else can we do to yet do better than Bob and what Sally is suggesting?